All right, so if we didn't have negative indexing, we could do this thing where we took the length of that string and subtracted 1 from it to get the last element, right? Because the length of S is 4, minus 1 is 3. So that last letter is 0, 1, 2, 3. M is position 3. But this is cumbersome to write. It also takes, the computer has to calculate the length of the list and then subtract 1 from it. That takes a longer amount of time than just doing it this way where we use a minus 1. So if we wanted to spell the word backwards, we could do S minus 1, minus 2, minus 3, minus 4 to go backwards. So that's indexing. There's a related operation called slicing, where you don't just get one element or one letter, you get a substring in the case of strings, or a sublist in the case of if we're working with a list. And this will this works sort of similarly. So if we do a slice from 1 and then we put a colon and a 3, this will get us from element 1 to 3, but not including 3. So this is, if we go back to our example here, we said we wanted from 1 to 3, so we're going to start here, but we actually don't include the 3 in what we get out the other side. So you can kind of think of it as pulling out the front part of that slice. So when we write 1 colon 3, we're getting 1 and 2, but not position 3. The reason of this is related to why we start at 0, and it's that if we include that, we want to be able to specify that second position, but we don't want to include it because then we end up having the nice thing about this is that the substring that we get is 2 characters long, and 3 minus 1 is also 2. So the sort of dimensions of that slice are equivalent to what we get out the other side. In computer science, this is called a fence post issue. So the reason it's called a fence post issue or a fence post situation is that if you wanted to build a fence that was 4 lengths wide and you had a post between each one, how many posts would you need? So 1, 2, 3, 4. You'd need 5 posts, right? So you'd have a post and then a piece of fence and another post. You'd need 5 posts to have a fence 4 wide. So the same thing happens here. We want a slice that's 2 wide, but from 1 to 3, we think, okay, 1, 2, 3, that's going to be 3. So we actually don't include that third element. So that way, the length of that slice is not, we're not adding an extra element that we don't expect. It's harder to explain until you actually use it, and then you start to feel like, okay, this makes sense why they did it this way. Not all computer languages work this way, but this is how Python is designed. Okay, so if you want, you can either specify both the start and the end, and remember it's not inclusive, so it's 1 to 3 gives you 1 and 2, up 2, but not including 3. You can also do just give 1 index, so the front end. So I can say I want the first position, which is, or index 1, which is actually the second letter, and then up 2, but not including the end, or up 2 all the way through the end. I can just put an open-ended colon here. So instead of saying, I'd have to do, if I wanted to use this style notation, I'd have to do 4, or I'd have to do, I'm not even sure if this will work. No. So yeah, you really want to, you have to do like a 4, which doesn't make sense because it doesn't even have a 4th index. So you just leave that open. You don't put anything there, and that will take you all the way through the end. Okay, so a couple more notes about this. One is that when we're doing all this indexing and slicing on S, this string, the value of S is not changed. So we've just been pulling out different pieces of it, but the actual, if we look at S by itself, nothing has been changed. Now, if we wanted to do this, here we got everything but the first letter, so we start at 1 and go to the end. If we want everything but the last letter, we can start at the beginning, which is just, we just don't specify, we just put the colon there, and then go to -1, which is the last position. So we could have put, if we had put a 3 here, we'd get the same answer, but the problem with that is that we need to know that 3 is the end of the string. If we put -1, then no matter how long S is, we're always going to get everything up until the last letter. If we want the whole string, we can actually just put a colon there. What this will do is give us a copy of that string, which can have advantages in how Python handles the information. So I've just put a little review here, the index position of these characters, and how the indexing works. So this is just a review of what we just went over. So to show those examples, you can see the first 2 letters, the last 2 letters, start counting from the back, and the everything but the first 2 letters and everything but the last 2 letters. So to specify that with a longer string, here we have, so I switch what I just said a little bit. So with the :2, we have just the first 2 letters. With 2: we have everything but the first 2 letters. With -2: we have just the last 2 letters. And with :-2, we have everything but the last 2 letters. So did you start to see why using the numbering this way with the negatives and the up to but not including kind of situation is handy? Because so here, this is actually, that 2 is actually position 3 in the string, but when we slice it, we only get the first 2 characters. So this is handy. So if we want a slice, if we want the first 2 letters, we just put a 2 there. If we want everything but the first 2 letters, we just put a 2 there. Same thing, we want just the last 2 letters, we put a -2 colon. And if we want everything but the last 2 letters, we put a colon -2. So now we don't need to know how long the string is, and we don't need to think about, okay, which position is it? We just want the first 2 or the last 2, or everything but the first 2, or everything but the last 2. So this is where you start to see how this system is useful. Okay. So there's a few more things you can do with strings. And in fact, I'm going to do one thing with my notebook here. You don't have to do this, but there's this view menu, and I can toggle the header. And I'll just do that for now, but I can also toggle this toolbar and line numbers. I'm going to leave that there for now. It just gives us a little more space. So there's a few more things that we're going to cover with strings. One is repetition. So remember I said that Python is dynamically typed. So just like a plus sign is concatenation instead of addition, a multiplication sign, which is this star, is a repetition instead of a multiplication. It works a lot like multiplication. So if we type S times 8, we're going to get S 8 times in a row. And if we do a plus sign, we're going to get concatenation of these 3 letters at the end of S. Now, if we did want to change S, remember I said all these things we're doing aren't actually changing the value of S. We're just displaying different things, but S isn't changed internally. We can actually change S if we wanted to. So in this case, we're going to take S starting at position 1 to the end. So we're going to remove that first letter, and then we're going to add or concatenate a Z in front of it. So when we store it, we don't see anything printed because that's just happening. We have to actually type S and execute it. And now we see the value of S. So we've removed that first letter and we've concatenated a Z to the front. Okay, so
it doesn't like write it from left to right. It like looks at the whole thing first and then.
So the way that in this case that the concatenation works is Python is gonna evaluate these 2 expressions, and it's gonna evaluate this as just a Z, and it's gonna evaluate this as PAM. And then it's gonna say, okay, these are both strings. So when I do a plus operator, I'm gonna concatenate. So similarly, when S is a string, it inherits all kinds of other properties that strings have. So it inherits what we call methods. And methods are kind of like, they're related to functions, which we'll talk about later, but methods are functions that are built into a data type. So first thing we're going to do is we're going to reset S to be spam. So we're going to save it or store it again. And now we can see that we've changed S back to spam. So one thing that a string has, it has this find method, which will find a substring that might be in a string. So if we type s.find, we can see that the substring PA is found inside spam, and it's found at position 1. So remember 0, 1, so it found PA right there. There's another method called replace, and we can replace that PA with something else, say XYZ. So if we do that, we get this as the output, but S is not changed. So if we wanted to save this, we'd have to do S equals S.replace. So that would take that, it would do that operation, and then we would store that then as the value of S. And so those are also done kind of in sequential order. So it does the operation before it saves it. So it doesn't get confused about like, which is it, the old S or the new S that I'm working with? It does it first and then it stores it. So let's find out. So you said, what if I find something? What if I search for something that's not there? So, and it returns a -1. So what it's doing is if it finds it, it's going to give the position in positive as an integer. So either 0, 1, 2, 3 as a positive integer, a whole number, I guess those would be. If it gives you a -1, that means it didn't find it. So that can be useful because you can say, we'll just can do this. Right, but if I do the same thing here, All right. That shouldn't work. Okay, I guess we have to do something like this. I haven't used this operator much, but so it'd have to be, yeah. So we could do something like this, where if the value of that expression is greater than or equal to 0, then we can say yes, it worked. Otherwise, it didn't work. This is a built-in method for strings, but we're going to cover a lot more examples of this. Is like a regular expression, right? Did you find this little piece of text inside a longer string? We're going to do a whole lesson about regular expressions, and we're going to see a lot more more sophisticated ways to do this kind of thing. And Python has a lot more. But yeah, it evaluates as -1 if it doesn't find it. So moving on, there's a few more methods. So let's create another string that's just some letters separated by commas. So the string object or string data type has a method called split. And what that does is it takes this character. So the way this works is you have the string, a dot, and then this method, and then in parentheses, if the method has some arguments, those go in the parentheses. Sometimes the method doesn't have any arguments. So like this one here, upper, is just changes the string to uppercase, but it doesn't have any arguments. So this would actually work for this line we just typed to. So you're going to see this a lot in Python, where you have some object. It could be a variable, or it could be a package or a module. But for now, let's just say it's some variable that you've created. So s, or line, is a string type of object. And then when you type a dot, that says, okay, I want something, some attribute of that object. So that could be something that you created, or it could just be intrinsic objects that come along with a string. So a string is a sequence of text, and Python knows that this object is this sequence of text, and all strings have some objects, or attributes rather, that that are inherited or that come along with that kind of object. So a string object has attributes find and replace and split and upper and is alpha, et cetera, et cetera. So in fact, if I add a cell here by typing A, and then I type S dot, and I hit tab, my notebook is going to give me this list of all these different things I can do with this string. I can capitalize it. I can count things. I can find a bunch of different stuff. Some of these I haven't even used before. There's all these different. Most of these are methods. Some of these are other kinds of attributes. When it's a method, let me see here. When it's a method, it has parentheses after it. So this is s.upper gives us, and parentheses will execute that method and give us the output of that, which is everything in uppercase. Is alpha evaluates whether it's an alphabetical string. Let me see if line evaluates. I think it should. Is not. So because it has commas, it's not considered purely alphabetic. There's another one called alphanumeric, also not. But if we did S that is alpha, and that would also be alphanumeric. There's a lot of different methods for these various different data types. I'm just showing you a few that are useful with strings. So a couple more. So we have this other variable we're going to create called line2. And if we just look at the value of that, you see that it's got a new line at the end of it. So the problem with that is that if we split that, so we take that and we want to split that into a list. This is a list here. We can tell because it has square brackets and then the elements are separated by commas. If we split that, the last element's going to have a new line character, which is probably not what we want. We kind of want all these to be equivalent. So in this case, what we could do is use this method called rstrip. And I'm going to print the value of line 2 here. So now we no longer have this new line at the end. And so when we split it, now each of these elements, that last element now no longer has a new line character.
What else is rstrip?
So the good question, there's another thing that I meant to point out a minute ago, is that we can do, if we do line 2 dot, remember line 2 dot, we can see all these things. We can go down to type. Also, if we start typing letters, let's say we know, I know that method starts with an R, but I can't remember how to spell it. We just type an R, and now we just see those things. So we type rstrip. If instead of typing parentheses, we type a question mark and hit enter, we're going to get what's called the doc string, which is like information about that method. So this says this will return a copy of the string with trailing white space removed. So this will strip, should strip new line characters and spaces. So if we did, let's do this. Let's do line 3 equals, I'm going to copy this part. You can either follow along or just watch me. I'm going to do a new line and then a space and then another new line, another space. And if we do line 3.rstrip, you can see that it gives us, it removes all the trailing white space. So white space is spaces, new lines. That's the main two. I can't think of any other white space characters. Tabs, yeah, we can see if tabs. It's a good one. Yep, tabs are also considered white space. Yeah, good call. So that's how rstrip works. In practice, when we start using pandas, we're going to import a CSV file using a pandas function, and that will handle a lot of this for us. But it's good to know how these things work, because sometimes you'll just be using a different kind of file.